This is a lesson on the periodic table. About the time that the biologists were organizing and classifying animals, the chemists were discovering and coming up with many different elements. So they were trying to figure out ways of organizing them. They did notice some early trends of the elements, like lithium, sodium, and potassium all react violently with water, and they form +1 ions. Fluorine, chlorine, bromine, iodine reacts with metals, and they form -1 ions, and there were others. The problem was the scientists who were trying to do this, couldn't put it all together. They could identify trios or things like that, but they couldn't get all of them to fit the pattern that would work. Dmitry Mendeleev, was a Russian. Russians at that time were not held in great esteem, so this is even more remarkable. Mendeleev had 3 parts to his first successful periodic table. The first part is he ordered the elements by mass. Most of the other people who have done this did the same thing. That's not new. He grouped the elements by properties. The thing that he did that others did not was he left gaps, saying that there were undiscovered elements. So Mendeleev had these things that he did, and this is the key one right there, that he left gaps. The other people tried to fit the known elements into a pattern. Mendeleev held that the pattern was more important, and the elements could have been found that they're not there yet. They haven't been discovered yet. Not only he left gaps for these undiscovered elements, he also made predictions. He predicted density, color, reactivity with oxygen, mass, things like this for these elements. Now, the other people at this time thought Russians were mystics and crazy people, like Rasputin. Long hair, wild eyes, crazy people. So they're all snickering at him, doing this prediction thing like he was a magician or something, until they found some of these elements that he predicted, and he was almost dead on the correct properties. Anytime a theory can make predictions based on that theory and they come true, that leads credence to that theory, so it's backed up. People tend to believe it. Now, Mendeleev's periodic table is not the modern periodic table. One thing is there were no noble gases discovered at that time, so they had to add that entire group. Other things that were not done is he ordered them by mass, and sometimes the masses go down and then they come up. Nickel and cobalt are a pair that does that. They go down 0.2 and then they go back up. So the modern periodic table is no longer ordered on mass, but on protons, on the atomic number. So every element has one additional proton to the neighbor to the left, and this keeps on increasing that way. So the modern periodic table is based on the number of protons, not the mass. Also, the grouping, they are no longer grouped by properties, but by electron configuration. Everything in the, I'm going to draw a rough periodic table down here. Every element in this column here has S1. Hydrogen 1s1, lithium 2s1. All of these are S1. They all end with S1. So instead of doing the properties, they do electron configuration, which is what determines the properties. If you know the expression beauty is skin deep, chemistry is outer shell electron deep, because they only concerned about the outer shell. The inner stuff doesn't really matter to the chemistry people. So how the outer shell looks tells you a whole lot if it's going to lose or gain electrons or share electrons. This group here is the S2 group. Every single element here ends with S2. So they are now grouped in columns by electron configuration. So the columns are that way. The parts of the periodic table and things, periods, go across, are the rows. First period, second period, third period, on down. So each row going across is a period. Groups or families, and we'll talk about the difference, are in the columns, or they're vertical. So these columns have special names to them. Not only this column right here is the all in with S1, they are also given a name, and these names are as follows, and this is going to be on the quiz. This is the alkali metal group. This is the alkaline earth metal group. Over here is the noble gases in the far right hand side. Next to it is the halogens, like a halogen lamp, very bright lights. Now, the book has some other things, I'm going to name them differently. The top element here is B, boron, so this is the boron family. The top element here is carbon, so that's the carbon family. This is the nitrogen family, and this is the oxygen family. They're families because the metals and nonmetals, they don't all have identical properties, because some are nonmetals to the top and some are metals on the bottom. And in between are the metalloids carbohydrates or semi-metals. All these other groups, alkaline metals, alkaline earth metals, noble gases, halogens, they all have the same properties all the way down to the bottom, or similar properties. In here in the middle is the transition metals. They are between the alkaline metals and earth metals and the heavy base metals over here. And the two rows that are detached are the inner transition metals. And the reason they're detached is because the periodic table would be way too long. This fits on a nice 8.5 by 11 sheet of paper. If this was put in here where it really belongs, then the periodic table would be very long and not very high. You could not get enough details into it to do any good. These groups here, this is filling up the S1 group, the alkaline metals are filling up the S1s, the alkaline earth metals are filling up the S2. Together, this is called the S block, and they are 2 elements wide, and you can put S1 and S2. Down here, the transition metals, they are 10 wide, there are 10 elements across, and they are known as the D block because the last electron being placed in here is filling the D block. The inner transition metals are 14 wide, which means they are the F block. And finally, over here, without hydrogen, which is an exception, we're going to talk about that in a minute, this is the P block. Now here, hydrogen, or helium is S2. You would think it would fit in here, but it doesn't because it doesn't have any of the properties. What it has is a full outer shell, 1s2. And full outer shells tend to be inert. So that is why it fits here, because everything else, neon on down, have a full outer shell, so they tend not to react. So that's how the periodic table matches up with the blocks. And that ends this lesson on the periodic table.